I would like to welcome all of you to our event with Jim Hollan today. I think lots of you know Jim already, and I'm really excited to be able to introduce him today because it was maybe my second year on the faculty at Stanford. Jim did his sabbatical with Terry Winograd and I in our group there. And Jim sat in on my graduate class, which was a real honor and a little bit daunting. And he came up to me after class one day, and he said, "Wow, your class is really great, but I have one small piece of advice if you're interested." And I was like, "Yeah." So he said, "When you ask a question, you always immediately start talking right afterwards." And he's like, "If you wait just a couple milliseconds, you'll be amazed by if you let that silence hang in the air, how much more interesting the discussion becomes." And I think that that's one thing that we can learn from Jim's career in general, is that I think he's one of the people who is one of the best listeners in our field. And so we're here today to listen to Jim, in part because he's the one who taught us how to listen. And sure enough, in class, one of the biggest changes I made in teaching that I now tell any colleague who will listen is after you ask a question, take a moment and just let the silence hang and see what people have to say. For those of you who are walking in or new to Chi, I wanted to tell you just very few things about what Jim has done. I'm going to let him tell most of the story. Jim has he's done a number of things over his career, including he was one of the people who was in cognitive science very early on at UC San Diego. Over his life, he has been a department chair. He has run a research lab. Many of his former students and colleagues are in the audience here. Back at San Diego with Ed Hutchins, Jim created one of the first big undergraduate specializations in human-computer interaction. It was a very early, very influential program in the cognitive science department. And I think that curriculum just does an amazing job with marrying the H, the C, and the I together. I think it's a real model for that. Also, Jim is without question one of HCI's most effective undergraduate mentors. After I joined the cognitive science department at San Diego, I am amazed by how passionate and dedicated and excited the undergraduate alumni are who come back. They're an extremely engaged bunch. Jim has several back to speak in his classes. They come back, they have dinner with us and give us advice on the program. It's a really awesome group. And lastly is I think that I hope my opening story shared that Jim has been one of the most powerful mentors in the field of human-computer interaction. I think we're in a really lucky field. If you look at how massive this event has grown, and it hasn't been all that long. And I think the rapid growth and the success, and in particular the intellectually ecumenical nature of Chi, is due to the leadership and mentorship of people like Jim. And so let's welcome him to the stage.
Okay, let's see if I can be heard here. Since I'm a listener, I try to speak. It's an incredibly great honor to receive this award. And probably as much as anything else, I owe any success I've had to selecting brilliant collaborators and wonderful students. Science is surely a social collaborative activity, and I've been incredibly fortunate in that regard. And to honor them, I'd like to sort of share this award with them. And I didn't have room for everyone. In fact, as walking around the conference, I'm already embarrassed of people that I left off of this list. But anything I've done has really been done in collaboration with other folks. And so I'd really like to share the award with them. It was super to get introduced by Scott, my colleague now, and it was fantastic to sort of attract him and the equally stellar Lyra Borodetsky to UCSD, and so we've had a series of really interesting events of late. This past summer, we were able to attract Don Norman to boomerang back to UCSD. Don was there and when I first got there and had been there for quite a while before. And together with Scott, Don and I are starting a new design lab at UCSD, and I'll mention it briefly a little bit later. And personally for me, all of this came at a really good time. My colleague of over 30 years, Ed Hutchins, from whom I've learned probably more than anyone else about this area and about people and about distributed cognition, decided to retire last summer. And I thought, oh God, I've shared a lab with Ed for all this time. What am I going to do now? And so just then Scott shows up and Don shows up, and we're starting a new lab, so it's really great. And also really happy that Ed is following in Don's footsteps. Don is probably one of the most successful failures at retirement that ever happened. He's retired from many places now, and now is back unretired at UCSD. And Ed only lasted the summer, and now he's back with us again. So I'm really happy for that. So I was trying to think a lot about this. Well, I was really procrastinating last night, making this list of names of all the folks, and fearful that I would leave people out, and which I have. But I want to do three things. I want to sort of share a little bit of what my excitement is about the field, and why I think it's such a crucially important time for HCI. It was one thing in the early days when each of us sat with a little Mac on our desk, unconnected to anything else, and tried to design systems. And it was hard enough to do that. But now we're faced with a very different world, and we're crucially part of just every system that's being built. So I'm going to talk a little bit about that, maybe a little bit too much, but I think I'm envious of all the young folks here. You're coming into the field at exactly the right time. If I could have chosen when to enter the field, it would be now. And then I'm going to tell you a little brief story about my path and some of the lessons I've learned. It's been quite a pleasure to sort of reflect back on sort of a 30 or more years of working in the field. And then I spend a little bit of time talking about challenges and opportunities, and try to throw in a little advice along the way. I think it's really all about stories. I've always been very taken by the Nobel laureate Peter Medawar when he talks about science, and he says, science begins as a story about a possible world, a story which we invent and criticize and modify as we go along, so that it ends up being, as nearly as we can make it, a story about real life. And I think that that's what science is really about. But I think we have, in our discipline, we have an incredible advantage because we can sort of make at least some of our stories true by writing code and building systems. And I think that that's a tremendous advantage that we have. So anyway, so exciting times. I think probably the most positive thing that I see in the field is that we're moving away. I think for way too long we've conceived of thinking as something that happens exclusively in the cranium, in the head. And when I started off, I surely thought about thinking very much that way. But I think we all sort of realize now that thinking happens in the world as well as in the head. And we think with things, with our bodies, with marks on paper and in the sand, and with other people. And that thinking is sort of a distributed social activity that exploits these wonderful facilities of language, all the kinds of representational media that we have, and our embodied interaction with the world and with other people. And today we sort of increasingly think with computers. And I think that that's one of the reasons that this is such an important field, because we want to build kinds of systems that are really allow us to think thoughts that we couldn't think without computers and other people. But it's not the computer we grew up with. It's certainly not the computer I grew up with, kind of thing. When I first got to UCSD, there was a big Burroughs 6500 in a room with a lot of air conditioning and glass windows, so you could sort of look in and at it, and you could put, give your cards to someone to read into the computer, and a day later you could come and get a printout of that little syntax error you made in your program. That monolithic computer that we grew up is really coming apart. And it's being reassembled in myriad new forms. And the boundary sort of between people and computers and between physical and digital worlds is becoming increasingly blurred and permeable. Things are moving back and forth along that thing. We talked today of being on the threshold of what people call the age of an Internet of Things. And I think that's not quite right, kind of thing. It's really more than things, and people always have to be in the picture. So I think we're really moving towards an internet of everyone and everything, kind of thing. And that's, again, one of the reasons that this field is so crucially important. And recently I've sort of been thinking about why the movement is happening so quickly. And part of it is Moore's Law, and part of it is all the sensors, and part of it is, the world getting networked where I can be connected everywhere. But more and more I'm sort of thinking it's also this changing cost structure where we can do things that we would never, ever even conceived of before, where the price of using 1,000 computers is the same as using one computer for the same period of time, kind of thing. And that's radically changing things in what we can do and the way that we can do it. It's fundamentally changing the world. And interaction is not sort of moving, but it's rushing towards away from the desktop. And I recently helped organize a Dogstill conference in Germany on interaction beyond the desktop. And just realized this growing zeitgeist of the importance of moving beyond the desktop is shared internationally with folks. Another reason I think that it's an exciting times is computation is really, Alan Kay had this wonderful expression that computation was the first meta-medium, a medium where we can build other medium. And for me, the thing that's appealing and exciting and attractive about computation is this incredibly plastic medium that we can, fashion representations and new kinds of interaction and new ways of communicating that we all experience every day. We can also mimic older media, so we can make the iPad look like a book and act like a book and change pages like a book. But we can also create these really wonderful new kinds of representations that are sort of unconstrained by the constraints of paper and other media. The models, I can now, I stopped in Hawaii on the way here to go surfing. And the models are such that I can know what the surf is going to be like on the North Shore of Oahu while I'm in San Diego and really deciding whether I should get on the plane or not, kind of thing. we can build these wonderful virtual worlds, which are now long past the sort of metaphorical desktop that grew up on the Alto kinds of things. Suddenly, these worlds can be, have all of the wonderful techniques of film and animation kinds of things. And I think we're, and probably see some of this at the conference, it's sort of just going to erupt these areas of virtual reality and augmented reality. The kinds of technologies are just coming to fruition, and they're going to be, I think, quite major for our field. And then we can also combine the real and the virtual, and things like computer augmented surgery. So, here's a Da Vinci robotic surgery system. The surgeon is sitting at a console, manipulating kinds of things. He's really dealing with a virtual world, which impacts the robot. This world allows him to take sort of trimmers and things out of his hands. It allows him to see, for example, doing a mitral valve replacement in your heart, which used to be this open where they crack open the whole chest. Now it's done with these arthroscopic kind of robotic things. He can be in there tying knots inside of someone's heart. That can be enlarged. He can be aided in doing that. That kind of virtual world is exciting when it's connected with the real world. And there's some problems with delay and stuff, but there's no in principle reason that the surgeon with special skills couldn't be operating on someone on the other side of the world, kind of thing. I mean, that's an exciting kind of thing, exciting times. But for most of us, lots of the excitement has come with the movement off the desktop and into smartphones. And here's Steve Jobs introducing the iPhone. And increasingly, we carry many of these. I sort of, usually travel with a phone and an iPad and a laptop and kind of thing. And some of them we don't even think about as being computers, although they are incredibly powerful computers. And part of the power is that they're connected to computers and sensors and people all over the world. So I can sit here and, chat with my wife before giving a talk here in Korea. And just all of our activities are increasingly mediated by computers. And it's changing just almost every aspect of our professional and personal lives. And I think often for good, but also often for ill. One of my students, Kevin Lee, came up with this great picture a number of years ago, which I can't stop using. And I think this is for ill. I think these young folks are missing something. And I had shown this a couple of times when I realized they could be texting each other. So it could be even worse than I think. And we're seeing, this movement off the desktop and into cars. In fact, I was surprised to see there was a motor show here that I would have been interested in coming to just before CHI. We've seen, Mercedes had this prototype car in the States recently. We know about the Google self-driving car kinds of things. And we've become interested in the lab in communication between cars and pedestrians. How is a car going to let you know when you're crossing a street that it's seen you? How are you going to communicate with that kind of thing? There's lots of really challenging issues as we get towards semi-autonomous and autonomous cars, and most of them are, HCI related. How do we relate that? And I came across this great video, and I'll play some of it. It's just too good to give you a feel for if you're looking at, say, an intersection in New York City. It might look like this. And you think about the communication now between people, cars, bicycles. large truck. But exciting times is also brought by all of these kinds of new devices. I mean, we've done a lot of work with Anoto digital pens, and suddenly, pens can record your writing, record what's being said while you're writing. You can put on a Google Glass, and it can record what you're seeing and tell you about what you're seeing. There's light field cameras coming out where you can take a picture and only today then be able to refocus it after you've taken the picture. There's, cars are just becoming computing platforms, all kinds of devices, heads-up displays, all of these kinds of things, all needing the help of our discipline. Today, everyone's excited about the watch, about to be available. You can go and try it on, kind of thing. A million were ordered on the first day, kind of thing. I think a million more at least has been ordered since then. People are excited about this wearability kind of thing. The Pebble Watch was one of the biggest Kickstarter kinds of things, over $10 million of people invest. Pardon? I don't, just, oh, yeah, that's good. So the Pebble Watch, largest, sorry, I'm a listener, as Scott said. So, I was thinking about this, and, one of the first watches, I'm not a watch person, but I was excited when this watch came out. And I don't know if, maybe few of us are old enough to sort of remember this watch. That was a Commodore Watch from the 70s. Some of you might still remember the Commodore 64 microcomputer. It turns out the Commodore was a watch company before it became a computing company. And it's sort of interesting to see companies maybe starting to go the other direction kind of thing. One of my students brought me this wonderful cartoon I need to share with you about this brief, glorious period when our wrists were free kind of thing. And I think both in thinking of the Commodore early computer and that, I think so here I'm going to throw in my first piece of unsolicited advice. And I think our field needs to spend more time knowing the history and the literature of our field. I think ideas have histories and can really only be understood fully in the context of those histories. And that's a message that Bill Buxton has been delivering to us for quite some time. And I think both he and Terry are not only sources of great counsel and wisdom, but also have provided really valuable online resources. I think Bill's 30 years of examples of interaction techniques and interaction devices is incredibly valuable to look at. And I think we all owe Terry an incredible amount of praise for starting the people computing and design seminars at Stanford. And now there's approximately 25 years of very influential talks. So one piece of advice is to go back and look a little bit at the history of the ideas. Another reason for exciting times is I think we're in the midst of a sort of data revolution. Not just the big data that people are talking about, but sort of more thick data. Data of people really interacting. Sort of inexpensive digital recording devices and video have revolutionized behavioral science. So suddenly we can look at things in ways that we never could before, and we can capture. This is my colleague Ed Hutchins when he had more hair and when he was young. And this was when he was doing his PhD field work. Ed's a cognitive anthropologist, and he was doing his PhD field work in New Guinea, looking at land litigation when someone dies and how things are passed down, and people get together in the village, in the square, and discuss this kind of thing. And Ed wanted to understand that, and he's new to the language, he's new to the culture, but this, you can almost see it here, but he's got this thing around his neck, and it's this great big square thing. It's a battery-powered tape recorder. So for the first time, you could take that into the field and record what people really said. And if you've ever listened to what people really say, even yourself, it's a very startling kind of experience because it's very different than what we hear, kind of thing. And so Ed was able to study that, and I think we're sort of at a period where we're able to do that in ways that were just unimaginable just a few years ago. I'm very taken by the work of Chuck and Candy Goodwin, who are at UCLA currently, and they've looked at all kinds of really interesting activities of like children playing hopscotch, all the complex things that are going on and the way kids use their bodies and their facial expressions and things to communicate their intentions and that. The elder gentleman in the bottom picture is Chuck's father, and he had a stroke in left hemisphere, and he could only say 3 words after the stroke. He could say yes, no, and the word and that was his vocabulary. And what Chuck was able to document and begin to understand is how his father was still an incredibly active participant in conversation, was able to get his intentions over to people, was able to accomplish what he wanted to do by facial expressions, by movement, by pointing, by all of this kind of thing. So I think we're at a really interesting time for looking at what people really do, and I think that we don't do enough of that. I think we don't know enough about even what we do, kind of things, and we have an opportunity now to do that. Okay, so I'm going to talk a little bit about sort of my research path and sort of my story kind of thing. As a young kid, I was about as nerdy as they get, and fortunately I was an only child, so I could be even nerdier kind of thing. And I got involved in math. Math was sort of my thing. And I particularly got involved in studying mathematicians' lives and reading novels, and not novels, I mean stories about mathematicians. There's one famous one I remember, Who the Gods Loved, which was written by 2 mathematicians about Rusty Galois, who invented group theory, who died in a duel as a young man, who couldn't get into the École Polytechnique because you were supposed to solve the classic problems in the classic ways. And Galois came up with a new proof every time and was not allowed in. So mathematicians were really interesting to me because they were weird and they were doing cool things, and I was totally taken by things like Cantor's diagonal proof, where at first I could sort of see that, that I could understand something about uncountably infinite kinds of things. And so I thought, I'm going to be a mathematician, and I scored high in this math Olympiad, and everyone painted me with a math brush. So I went off to college, and I unfortunately got bitten by the what was then called the 4-color conjecture. If you don't know this thing, it's the conjecture was that it only takes 4 colors to color any planar map, so that across any border it's different colors. And this had been a long-standing problem, which was sometimes called the 4-color disease, because it had been passed down from one generation to the next, where the father or mother worked on the problem for a period of time, and then son or daughter worked on the problem. So it's very easy to map this into graph theoretic kinds of stuff, and I got really interested in graph theory, and I became obsessed. I was totally convinced that there was this monster counterexample, that's the reason that no one had ever proven this, and I was going to find it. Unfortunately, a few years later, it was proven to be true. But what I really found was computers and programming, and I used massive amounts of time on the computing systems looking for counterexamples needlessly. And then I came across a book by George Polya, How to Solve It. And it really changed my orientation. Suddenly, I became much more interested in how people do mathematics and how you come up with conjectures and the whole cognitive side of things. And it sort of resulted in me wanting to became a double major in math and psychology, and almost no one in psychology wanted to talk about the things I wanted to talk about in those days. And I went to graduate school, got married as an undergrad to a woman who wanted to go to med school. She was only admitted to one medical school. In fact, it was sort of the last year that it was really difficult for women to get into med school. There were 4 women in her med school class, kind of thing. And so we went a place which she was accepted. I didn't think it was a good place for me because no one was interested in the kinds of things I was interested in. But it turned out that was probably the best possible place to go because I was sort of on my own, and I had to sort of make my own graduate experience. And then I was very fortunate to be accepted a postdoc with Pat Suppies at Stanford in the Institute for Mathematical Studies and the Social Sciences. But that wasn't really the right place for me either. I thought it was. But I started hanging out at the AI lab and at Xerox PARC. And that sort of totally changed my life because I found the Alto and I found Lisp machines, which was love at first sight. And I at the time I didn't know what I was going to do, but I knew I was going to do it with machines like this, that they were just so interesting and there was such possibilities representationally with them. So anyway, so the phases of my life, these are not all decades. The 2 in the middle are half decades kind of thing. In fact, the unit of time I think about or try to think about is decades now kind of thing. And I spent the first decade at UCSD and also because my wife by this time was a resident in surgery. I had plenty of time, so I had 2 jobs and still felt like I was loafing. We built some systems, and I'll tell you a little bit about them in a minute. And then I left to go to head up the Human Interface Lab at MCC. We built some more systems and did some other work. And then I left there to go to start a group at Bellcore. And left there to be chair of computer science at the University of New Mexico, and then finally boomeranged back to UCSD. So the early years at UCSD, again, it was the 2-body problem that really led me to UCSD. It was the only place my wife was accepted into residency in surgery, but it turned out to be a really, really amazing place in those days. I mean, it was. I was so lucky and so fortunate, not the least of which I started to learn to surf, which was also an incredibly important event. But it was intellectually, it was the most productive, interesting environment I think that I've ever been in. It was this great collaboration between Don Norman and Dave Romelhart, and then Jay McClellan joined. And we were sort of transitioning to form the first cognitive science laboratory there. it was really the beginnings of cognitive science. About the time I got there was the first cognitive science conference, which was held at UCSD. It was the first mental models conference was held there at UCSD. We had this wonderful Sloan Foundation postdoc program where we were able to attract this whole host of just incredibly enlightened postdocs. I mean, Ed Hutchins was one of them. Jeff Hinton was another one, and it went on and on. We had this amazing set of graduate students. Abby Sella and Bill Gaver, Bob Glushko, Jonathan Gruden, Mike Jordan, Mike Mosier, and on and on. It was the beginnings of this whole connectionist movement and a very different view of cognition. The original parallel distributed processing books were being written. And Francis Crick, the Nobel laureate, used to sit in on our meetings and berate everyone about how little they knew about the brain and how foolish their models were. But it was just an intellectually incredibly stimulating kind of environment. And at the same time, I was able to maintain ties to Park and what was going on there and be a consultant. And I convinced the Navy to give us a bunch of money to buy these really expensive list machines. And we built a number of systems. One of them was a navigational training system. And what we were really interested in is, I think in the slide it said the buzzword or the slogan of the day was conceptual fidelity rather than physical fidelity. So it was the time of mental models. It was a time of concern for how people thought about these things. And could we build systems that aided the building of those models? Not the models that you get in physics textbooks, the models you think with. And so we built a series of navigational training systems. Some of them on a little computer called a Terac microcomputer. It was a little LSI, a level 11 computer built in Arizona. That was one of the first bitmap, really inexpensive displays. I was involved with Ken Bowles, and we built UCSD Pascal, this really interesting system. We had some of the first PERC computers, which you probably never heard of. They were done by a spin-off of CMU and informally called Pascaltos because they were like Altos but ran Pascal. And these were pretty successful. Our training systems on the little micro went on every ship in the Navy. I had chiefs who'd taught these kind of navigational things for 15 or 20 years have light bulb experiences because they had taught these procedures by rote. And suddenly they could interpret. Lots of things we did was mapping between representational systems, the kind of relative system that you get on a radar with a geographic kind of map-based system kind of thing. The PERC thing, we built a bunch of tutoring systems on, and I installed one of these on a new nuclear carrier that was just getting commissioned, the Carl Vinson, with, I still remember, Captain Martin, who was the commissioning officer for that ship. It was very strange to install it on that. So we built these systems that were really primarily cognitively motivated by trying to help people build the kind of models they needed to reason about things. We also built a system called Steamer, which this is Louis Weitzman, one of the guys who worked with us. This is on a MIT list machine, a symbolics list machine. The display on the left is sort of a dynamic graphical view of this complex dynamic system. There were lots of really good ideas. We could show the flow in the system. You could see the causal topology. You could view it at many different levels. We built some of the first kinds of qualitative graphical components. So lots of responses and systems like this respond to rates of change, to sort of derivatives of things. So we built these derivative icons, were just arrows that pointed up or down, and the size of the arrow said how fast they were changing. And you could step through the simulation and have this graphical instantiation of what seemed very close to what experts would discuss in the way they would describe the system. So we had a lot of fun. And about that time, we sort of stepped back from this, which I think is a really good thing. And Ed and Don and I wrote this original direct manipulations paper where we were responding a little bit to Ben Schneiderman's direct manipulation paper, which was very influential. But we saw it more as a checklist kind of theory, and we wanted a much more cognitive theory of what was going on, and so we tried to do that, and first instance of it was in this user-centered system design book, which was named that because we could get the UCSD acronym, and it was a very, I think, influential book, and the whole movement to sort of user-centered design, I think, was influenced by it. So the lessons sort of learned from that phase is, that I'm just more and more convinced that computation is this plastic representational system, and the work there is convinced me even more. I was sort of also very taken by how interesting and fun it was to build systems and then transition them into use, and that was both incredibly challenging, but also I think it leads to better science if you're able to do that. I mean, you have to deal with issues that you might avoid otherwise, and I think it continues as sort of this kind of relationship, that got introduced to me by Ed Hutchins, where Ed spent a lot of time in the bowels of Navy ships, looking and observing how people really operate them, and just how valuable that was to systems builders, kind of thing. It's really one of the big lessons of my career. And the other thing, we built this graphics editor, one of the first object-oriented graphics editors for building interfaces, interactive dynamic interfaces. And I was incredibly struck by how powerful building tools to build interfaces were, and how you could leverage that. In fact, at the time, we thought momentarily of doing a startup before that kind of thing was really prevalent. And the scary thing is this company was willing to give us a bunch of money to do that. And the idea was to use this graphics editor to build instances of these kinds of interfaces for all kinds of things, nuclear power or other kinds of complex dynamic systems. But we quickly realized that we would move from a research career to a different career, and ran quickly in the other directives. The other thing was the importance of sort of really abstracting out the cognitive design principles. I think this direct manipulation paper was something that sort of taught me that you need to do this kind of building kind of stuff, but then you have to step back and really abstract out what you've learned from it. And then the other thing that was reflecting back on this, that we were just so incredibly naive about the scale of the project that we took on. I mean, this, a huge, the first thing we're going to build a graphical dynamic interface to is a steam propulsion plant. Just this very complex kind of thing. And sometimes, and I think in this case it did, that leads you to do more important things than had we started much smaller. So anyway, so I left UCSD about this time, due to listening to the advice of Don Norman. Not always the best thing to do. And I had been consulting at MCC for a while, and it was a very interesting research thing, really wanting to do long-range research, had a lot of money, had a lot of good people, and they offered me the job of being director of this really large 30, 40 PhD lab, which I didn't want to do in any way. But I really wanted to keep consulting because it was really interesting. They had a lot of list machines and they were doing interesting things. So I asked Don, well, what should I do? How can I say no in a way that they'll keep me consulting? He says, well, simple, Jim. Just ask for a lot of stuff. And that sounded like reasonable. So I asked for all these sort of pretty outlandish stuff in my view, and they said, sure. And so I was like, I didn't know what to do, and it seemed like an opportunity then that it didn't seem like before, and so I went off to MCC. And we started building, sort of building on what we had done with this graphics editor, but extending it to be tools to build multimodal interfaces long before many people were ever thinking about multimodal interfaces. And so we were building tools to aid the construction of, natural language interfaces and graphics and gesture and intelligent systems that would give advice. And it was sort of, at a time of a heyday of AI, and we were not necessarily convinced that that was the right way to go, but we were really enamored of representational languages. And so we did a lot of interesting things of representing the whole system in this representational language. So not only the interfaces, but the tools themselves had representations. And the main idea that was sort of driving me and driving the development was an idea that I think still has a lot of credence. And the idea was that somehow when you're building systems, you have to get from this bit shuffling level of computing to levels that people really care about. And most of the time we think about doing that in maybe one step. We build an editor, or we build one kind of development environment and stuff. And I think the novel idea we had was that it's really going to take a series of tools, and that the important thing was that those tools were all connected to each other and sort of live, so that you could go in and make the changes at an appropriate level for the thing, and it would be for the whole system. So as you moved up the tool chain, you would empower people with different levels of expertise. But you would keep the whole thing tied, and I still think that's a really interesting and valuable idea. Another thing we did while I was at MCC is my car broke down. It seemed to always have cars involved. And I'd been out to dinner. Marvin Minsky used to come down to visit Doug Linnett at MCC. And we would sometimes go out to dinner at Lake Travis at this Mexican place there and sort of argue. Both Marvin and Doug love to argue, and I was bringing Marvin back one late night from there, and we broke down out on this, just the most deserted road you can ever imagine, and only in Texas can you sort of imagine these kind of really deserted roads. And anyway, long story, I ended up in this auto repair shop the next day getting my car fixed. It was an old Porsche. My folks in the lab had given me this bumper sticker. My other car is a piece of junk too, which I didn't appreciate. And I was there looking at it, and the thing that fascinated me, I just became enraptured by these manuals. And the thing that was interesting about them is mechanics have dirty hands. And when they deal with these manuals, the places that they deal with the most get the dirtiest. And I became really taken by that notion that people do things and it has these kind of representational consequences. And then you sort of start to see it everywhere. I mean, you see paths that form where people just walk, and it leaves these kind of things. You start looking at your paperback books, and they sort of open to the place you last read as you sort of break the spine at it. And so we did a lot of work. We got sort of taken by this notion. We did a lot of work on what we called in the day editware and readware kind of thing, or more generally sort of history-enriched digital objects. And we built some interesting, I think, ways of visualizing that. We built these what we called attribute map scroll bars so that we could represent that history of who edited, maybe how long they took editing, the co-editing of stuff, whether it was, it's long before the days of, track changes in Microsoft Word. We modified a version of Emacs to do all of this kind of recording. And it was really, I think, really nice to make it in the scroll bar because you used real estate that was already there, and you just touched the place you wanted to look at, and you were taken there. So it was really good. And we got really involved with that. So we had this idea of menuware. So, the history of your use of various features in a system should show there. We had bufferware, so how much time you spent on buffers. We had readware in our email readers, so you could tell how long. So one of the things we played with was these kind of messages that might go to everyone in a research group, and you're away and you're coming back. Wouldn't it be nice to see how long an average people in your group spent reading those? So you might prioritize things in terms of the things that people spend a lot of time reading. So anyway, we got really enamored by that notion. And I still think this sort of general notion of in a computational medium where you can capture kind of activity and then re-represent that in ways that inform tasks and do things. So you're not asking people to do anything. So the lessons learned is, first lesson that I learned at MCC was I had no skill in being able to manage a 40-person lab. My whole management philosophy up until that time was jump in a car and go to lunch and talk about things, and walk around and chat with people. And suddenly I sort of realized that doesn't scale. And that was a real lesson learned for me. Again, I was sort of, the lesson was that building a system is really a great way to integrate research and integrate people's activity and keep you on course. And it focused things in a way that I think most of the successful research projects I've been involved in have been tightly tied to building something, building a system, and using that as an integrating kind of thing. I think this tool chain idea is still worthy of a lot of consideration, that we're still trying to jump these massive gaps in building systems, and we try to do it with a programming language, or we try to do it with one tool. And I think until we have a series of tools like that, we won't be able to do it well. And this key idea about history-enriched digital objects, that you just let people do what they normally do, but because they're doing it in a computational environment, you can re-represent that in ways that will inform. I think that's a very, very powerful kind of idea. And again, I'm further and further convinced that computation was this plastic medium. So I left MCC in Austin, Texas, reluctantly in some ways. MCC was fairly successful, but as we see all too frequently in long-range research places, they seem to slide backwards into being concerned with shorter and shorter time frames. And MCC and the HCI lab were starting to do that, and I wasn't interested in that. So I left, and I formed a group at Bellcore called the Computer Graphics and Interactive Media Group. And I'll speed up a little bit here so we'll get finished on time. And it was right at a time where we were really interested in these dynamic graphical kinds of interfaces. And it was really clear to everyone that inexpensive graphic cards were on the horizon. And suddenly, every PC was going to have the kind of graphics that we only had on high-end SGI machines and LISP machines and very, very expensive machines. And so many people got very involved. This was the time that Stu Card was starting up work at PARC on the information visualizer. All of his concern with how we can sort of build dynamic, interactive, 3D kinds of interfaces. And we started building such a system ourselves that we had originally called ART, and the lawyers got involved. Every time the lawyers get involved, it's bad. And they said, well, there's commercial systems called that. You can't call it ART. And I said, well, okay, we'll call it AR3T. And, you know, because 3D and 3T. And then we'll tell everyone that the 3 is silent. And it's pronounced ART kind of thing. And so we were building this kind of very interesting system and visualizing big software systems and kind of things. And then I sort of linked up with Ken Perlin, who's a professor at NYU. And Ken had just put together this sort of very kludged together demo of a sort of multi-scale environment that he called PAD. And I thought it was just exactly on the right course. That is very hard to navigate in 3D, easy to get lost. 3D leads you to this kind of imitation kind of view, trying to make it like the real world. And 2D sort of multi-scale with zooming seemed like a really interesting thing. And so two of us in the group, a lot of the group was still very interested in 3D, and we did some stuff to make every polygon sort of zoomable and a 2D kind of surface. But I just hired a young guy from NYU, a guy doing robotic vision named Ben Peterson, and convinced him that he should get away from that and become an interface guy. And Ben and I became totally enraptured by the zooming kind of metaphor. And so we started building this PAD ++ system, sort of in homage to Ken's system. And about that time, I decided that Bellcore, again, was maybe not looking far ahead enough in the kind of research they were funding, and it was maybe time to go back to the academic environment. So I moved to the University of New Mexico, and Ben came with me there. And then I convinced DARPA to give us a bunch of money, and we started building this PAD ++ system, which I think was really influential too. One of the first sort of zooming interface. There were lots of interesting ideas about it, that notions of semantic zooming. So instead of just doing some geometric scaling, we did semantic kinds of things you got closer to. You might get a very different kind of view. We did a lot of work with lenses, sort of influenced by some of the PARC work. But also, you know, the idea, had a postdoc who came to study with me, one of actually Ken's students, who did this really interesting thing on sort of a principal way of composing lenses. And, you know, one way of thinking about lenses is doing a retrieval, but it's a very natural way of thinking about it. And then we also thought about using lenses as something you reach through. And when you reach through them, you can do various things. And being able to move those lenses around with a non-dominant hand and reach through, in effect, with a dominant hand was very powerful. This is Ben's file system in the day, so we could zoom in. Actually, yeah, I don't have many good images from those days, but that's the best I could do. Okay, so we did a lot of that. And when I moved to UNM, I got this big contract from DARPA, and I made subcontracts to sort of support my group back at Bellcore, which George Furness had taken over, and also Ken and his students at NYU, and then George moved to Michigan, and so we did a contract with George there. Another thing we did was just beyond being there work. And this, we just hired at Bellcore this young physicist from Stanford, Scott Sarnetta, And Scott and I sort of really hit it off, and we were both like going around seeing all the stuff going on at Bellcore at the day, and there was just a lot of work on video teleconferencing. I mean, I think the phone companies sort of foolishly thought that the way to the future was moving bits, kind of thing. And what we were both struck by is how much the focus was on imitation. That the goal was really being there. That the way the telecommunication problem was going to be solved by it was establishing this sense of being there. It's pretty clear that you could throw more and more money at it and get higher resolution graphics, and you get full duplex audio, and you could get closer and closer to being there. But what struck Scott and I both is that maybe that was just fundamentally wrong. That you were trying to imitate face-to-face kind of physical proximate reality in this computational medium, and it focuses you on imitation. It takes you away from doing anything that is distinctive and that you can only do in the computational medium. And so we started this Beyond Being There project, which we had originally called Better Than Reality, but that was a little too much even for us. And looked at that in lots of different ways. And I think learned a lot from it. The lessons really from Bellcore, when I reflect back on it, is that this idea of imitating one medium in another is just, not the best research approach. I think we found that both in PAD++, and also in Beyond Being There. And I think for me, one of the things that comes out of it is a kind of research strategy that I recommend for students is that you spend a lot of time when you're reading papers or when you're considering projects, really focus on the things that people aren't saying. What are the presuppositions? What are people sort of presupposing is non-controversial, is something you don't even have to say, kind of thing. And I think that that's a very powerful research strategy. Beyond Being There led to lots of interesting things. I mean, we did this kind of work on ephemeral interest groups and semi-synchronous discussions, and we did some of the original collaborative filtering kind of work in those days, and early recommender systems, and Scott and I did some follow-on work that we called negotiated access, which I still think is a more and more important topic that we tried to get. We got a patent assigned to a nonprofit so that someone else couldn't sort of take the idea. And I'm, as always, further and further convinced that this plastic representational medium is that. So anyway, so I head back after being at Bellcore and UNM to UCSD, and I started a lot of projects. I can't really talk about all of them here, but I want to mention a few of them. But I mainly want to say that Ed and I started this distributed cognition and HCI lab, which we wanted to promote this shift in cognitive science toward this broader view of cognition as really a property of systems, and that kind of functional approach, I think, is really, really valuable. Extending the boundaries of cognition beyond the cranium to include other people and artifacts and all those. And sort of the central image for all of our work is really, that we want to build environments in which people pursue their activities in collaboration with the elements of the material world, kind of thing, to look at that. And to do that, you really have to know what people do and how they coordinate their activity, and really to be really thoughtful about what role technology should play in doing that. So one of the first projects I got involved in was my daughter just had an automobile accident, and she fell asleep coming home from her boyfriend's late at night and crossed the median and had a head-on collision. Fortunately, she's okay, and fortunately, everyone was okay from it. But it sort of got me thinking about cars and driving and sort of realizing that cars are becoming computing platforms. And one of the things I'm often attracted to is sort of times when, new interfaces are forming in a technology. So attracted to digital pens and those kind of things because there isn't this established base and you can do new things. And cars seem to be like that, there were lots of new interfaces happening. So I linked up with a guy in electrical and computer engineering, Mohan Trivedi, and we wrote this big proposal. And we started looking at driving. So we bought a car. We instrumented it with 10 cameras so we could look at what people really do. We had cameras on people's heads. We had cameras looking at them. We had OmniView cameras on the top. We had the first ever foot cam. So we could watch what people were doing with their feet. We also were interfaced to the bus of the car so we could get all of the details out of the car in terms of what it was doing. And the data sort of looked like this kind of thing, where we were actually digitizing all of this information and the trunk of the car. And here at the top left, you see this very first-person view from a camera on the person's head. If you look down, we have other cameras. This is the first time this guy has ever driven this car. You'll note that he has one finger on the steering wheel. A little bit later, I probably won't get to it, he almost gets in an accident. He briefly touches the steering wheel with his other hand and then starts joking about I'm probably the first person that almost wrecked your car, kind of thing. And we got interested in interfaces and force feedback accelerator pedals and using pneumatic things in the seat to provide information. But what I really got interested in is I think I saw a bit of the future here, that it's going to be this kind of data that's going to drive design, kind of thing. And so I really got interested in building a system to aid that kind of analysis. And so one of my students, Adam Faust, me and a bunch of other people built a system called ChronoViz, which is really designed to aid field work, aid ethnographic kinds of investigations, aid things where people have rich time-based data, be it video, be it simulator data, kinds of things. And so this is an image from some work with Ed was doing with Boeing. So we have multiple video streams. This is from a high-fidelity simulator. So we're watching pilots in various tasks there. We have multiple sources of video. We provide really interesting facilities for annotating, that kind of thing. You're trying to understand it. You have to support how those kind of conceptualizations or ways of annotating it grow and change over time. We, in this case, can link it up to geographic and spatial data. We have transcript data that being linked in. We have a NotoPen digital notes that people are taking, and all of this is sort of time stamped, so we can link it together, and so we can sort of go from the for example, from your digital pen notes to video, so you can actually touch your paper with a NotoPen, have it drive the video to what was going on at the time you took that. What we find for ethnographers is this kind of facilities change the kind of notes that people take. That suddenly you can do things like just say interesting, or go back to, or that kind of thing. And rather than having to put anything, we get other folks looking at other kinds of things can record really detailed timing of those events just by putting dots on the paper, kind of thing. And I'm sort of running a little bit short on time. I was going to show you a bit of a video where we've implemented eye tracking in this kind of thing. And again, it's another timestamp kind of data. So we can do things, for example, like look at all the fixations on an instrument and then map that back to the actual segments in which people were doing that kind of thing. But I think I'm going to skip over that. And you know, we've used Chronoviz and all kinds of things, and other people are using it. It's open source. It's available at chronoviz.com. And currently we're using it, or we're looking at interactions in a medical clinic in southeast San Diego, and it's a really complex kind of situation where we have a physician and patient, and often an interpreter because of language kinds of issues. We've put a couple of connects in the environment, and we're doing sort of automatic annotation of some of that kind of data. Who's talking, who's pointing, when they're using the electronic medical records. But all in a goal to sort of ratchet up the level at which someone trying to understand this kind of complex phenomena is sort of placed. So anyway, so we're doing a lot of that kind of thing with Chronoviz, and we're now filming pedestrians interacting with cars, and we'll be doing analysis of that. We've also done a fair amount of stuff with Noto digital pins, very much inspired by Francois' work on paper-augmented digital documents. We collaborated some, worked with one of his students. And again, it's a very, very interesting kind of technology for us because it links up this kind of paper-based world with the digital world. And we've done quite a few different kinds of things in that environment. Some work in a children's trauma unit in D.C. where we're looking at taking, usually in the trauma bay there where sort of a code is saying some kid comes in with some awful kind of thing, people rush to the trauma bay. There's a recording nurse who's taking kinds of information. We thought it would be really interesting to let that person do exactly what they did. So we made that, print those things out on a note of paper. We can record that. We're looking at projecting that onto displays so that a doc coming in later doesn't have to interrupt to check on these kind of things. And again, it's sort of this wonderful thing of letting people do what they normally do in the way they normally do it, but because they do it in a computational environment, getting these added benefits. So we've done a lot of work in that area with a lot of it with Nadir Weibel, who came to do a postdoc with me. I was on his PhD committee in Zurich. But my favorite one of all times is some work of Anne-Marie Piper. Anne-Marie was the easiest student to advise of all time. You mainly just had to stay out of her way. And she was always like a couple of steps ahead of you. You know, I would say, I think we should really do, oh yeah, I did that last week, and I have those results, and oh yeah, I already have a draft of that paper. It's 3 months from now, but I have a draft. And Anne-Marie was also really good at sort of choosing doable research projects that were nicely scoped, which is a really art form kind of thing. And so Anne-Marie was going off to a birthday party for her great-grandmother who was celebrating her 105th birthday. And those are good genes to have. And so we thought of this project where we could print out a bunch of images on a note of paper, and she would take a bunch of pins with her, and people could point and talk about those kind of things, and it would get recorded so that her great-grandmother could experience this. She was mainly interested in family at that point. She had lots of images on her walls of family, but it was too far away to really see. Suddenly she could open up these kind of things and interact with this pin. And it was incredibly touching. Have these recordings of one of her 80-year-old daughters talking about an image and pointing to things and saying how she remembers that day and remember what we did after that. And it's in the voice of the daughter. So again, a really interesting kind of environment for interfaces. Lately, for the last few years, I've been looking at what I'm sort of calling activity-enriched computing, or again, sort of capturing and mining activity histories. I'm sort of returning to. And I had a student, Gaston Cangiano, who unfortunately died of cancer right as he was finishing his PhD dissertation. And Gaston had done this incredibly interesting study in a law office, immigration law office, and he sort of thought he was going to do a project about software to aid collaboration in this kind of office environment. And one of the things he started doing was just recording a bunch of screen captures of what people were doing. So you get sort of a movie of their activity. And he started replaying those movies for folks and just asking them to talk about what they were doing. And we were both like incredibly struck by how provocative that seemed to be in terms of people's, what they remembered. They seemed to remember all kinds of things of what they were doing at the time. Someone came into their office. I made a phone call about that. I meant to follow up on that. And so we both got enamored of maybe using that kind of thing to help people reinstate context. And so Gaston built a system that we called activity trails, which was sort of an episodic retrieval system. So he would capture all the text on the screen and everything everyone typed. And since real tasks, I mean, we have pretty good history facilities within applications, but real tasks are spread across applications. And so it would do this retrieval and bring you back to episodes, and you get little thumbnails of that, and then you could replay sort of a movie of what was going on. And I'm still, we just got some NSF funding to look at this, this more of this kind of context reinstatement. And I think it's a very interesting conjecture because so many things now are computer mediated, and there's so many interruptions, and they're so often difficult to get back into various activities. And lots of other folks have done work in this area, but I think it may require less than one imagines in that kind of thing. And the metaphor I have very much is that, you know, if you come to my office and look at my desk, what you see is a messy desk. And I probably, if I go to your office, I see a messy desk. But when I look at it, I see projects, and I see the things I'm going to take home, and I see the kind of, because it's my activity, it's my desk kind of thing. And I think that looking at recordings of your activity is similar to that. When I look at my recordings, yeah, running out of time. You know, we need to, I'm sort of thinking of my intentions, what I was doing and why I was doing it kind of thing. And I think there's this ability to exploit visual memory. So I'll finish up fairly quickly, but I want to say a little bit about this study because it really, it's this recognition memory study. It's, you know, a very classic kind of study that, you know, you're shown a series of images, and then you're asked to do a forced choice kind of thing, whether you've seen something before or not. But they did these really two other interesting conditions. By the way, you know, we're just incredibly good at that. I mean, we're really good at visual kinds of things like that. But they had these two other conditions. One of them was a condition where it was all objects, but you were shown a pair of objects that were from the same category. One you'd seen before, one you hadn't, kind of thing. And still people are like, you know, 80, 90% good at doing that. But then the sort of killer condition for me was you're shown the same object in a different state. And still people are like at 87% kind of thing. So, you know, seeing, you saw a picture of an abacus, and then you see the abacus with the balls in a different position, or that kind of thing. And I think what that leads me to think is that, you know, our visual memory is incredibly good, and if we can exploit that in retrieval. Okay, so I just want to end up with some future challenges and opportunities. You know, again, I think the opportunity all comes from this plastic medium kind of thing. I think actually our greatest challenge is being locked into the current way of doing things. We surely saw that in PAD++. It was just very hard for students to think of things other than in terms of menus and icons and that kind of thing. The image I often use of this is when I show you this image, it just looks like a, I don't know what, But if I outline it to show you it's a cow, and I go back and forth a couple times, then you can't see this without seeing the cow. And I think that it's equivalent in lots of kinds of things for interfaces, that we just lock into those kind of notions. In one sense, I'm really excited about things, but in another sense, it's sort of sad to see how little progress, in some sense, that's been made. Almost everything we do with computers is difficult and awkward and frustrating. Even after it's been 6 decades of evolution, there's just little of the naturalness of and the contextual sensitivity of working with other activities. There's not this conviviality that we have with working with paper and other kind of tangible mediums. The crucial, I think, in this is the unit of analysis that we've done. I think, in science, the unit of analysis is crucially important. And I think one of the key insights of distributed cognition is to be flexible about the unit of analysis. Sometimes the individual is the right unit of analysis, but often it's not. And I think for maybe too long, I think it's very much changing today. Our focus has been on the individual. The other thing I think very much is that we still, this presuppositions we have about information, about applications. I think we have some very unfortunate presuppositions about that. I think that we're sort of trapped in this spiral currently of apps where we're just building more and more apps for things, and I don't think that that's going to be the way to go to support real convivial, friendly kind of environments where we're sort of left to break everything into the right units of apps and then replace things back. And I think that we're also, one of the other presuppositions is that information is basically dead bits. I think there's some work, Google Now kind of things where things are sort of context sensitive and stuff. But if I had to put my money on where to invest, I would invest in building a very different informational infrastructure, that I want to think of as being sort of a cognitively inspired physics for information, that physics is such that the information is more active and context sensitive, and that we build things on top of that kind of thing. So anyway, I just want to end up, and we're interested in doing some of those things at the new design lab at San Diego and many other kinds of things, and I just want to thank just all of my collaborators and students and people I've been involved in, and I want to thank you for your attention, and it's a true honor